As usual, the first step is to load the toolkit talks file into the project. So I'm just going to drag that in here. And this tutorial is using version 0.13. And it's going to be using some features that are new to this version. So just make sure you're using either that version or a newer one. This tutorial is going to talk about 2D SDFs, or sign distance functions. The 3D SDFs that we use for ray marching, like box SDF here, which we connect that to a render 3D, and then add a null at the end here. And we can add a camera just so we can get a little bit of a different angle on it. So this here is a 3D SDF. And what that's doing is the shader that's doing the rendering is using that, that operator to figure out how far various points are away from the surface. So as it's casting rays through the scene, it checks to see how far is it from the cube, and it uses that to figure out where the surface is. So these SDFs in the main SDF category are all designed to work in three-dimensional space. So that means they work with coordinates that have X, Y, and Z. There's another category of SDFs called 2D SDFs that are similar, but they work with 2D coordinates, so just X and Y. I'm just going to set up our view here so we can get a little bit of preview on the side. So I'm going to set the display flag on this. I'm going to split the pane here. Set this to top viewer so that we can view it inside there, and then in here turn off background tops so that we have it shown in a separate panel on the side here and we can see our network. And just to make things fit a little better, I'm just going to set this resolution to something like 500 by 1000. Okay. So we're going to start by creating a rectangle SDF, and you may notice that most of the operators in this category have this, say SDF 2D at the end. There are a few of the older ones that will just say SDF, but usually the name of it, like circle or rectangle, kind of implies 2 dimensions. So we're going to start with a rectangle SDF here. And if we try connecting that up here, we're going to get an error. And that's because the RayMarch renderer is expecting an SDF that works with 3-dimensional coordinates. And this is only doing 2-dimensional. So there are a couple of other ways that you can use 2D SDFs. And the most simplest one is the render 2D. So this is similar to the RayMarch renderer 3D in that it takes in some operators and uses it to produce an image. But the way that it does this is a little bit different. So you can see that it is happy with a 2-dimensional input, but if you were to connect the 3D input, then it'll show you an error saying, input does not support coordinate type vector 3 or 3D coordinates. So I'm going to go back to the 2D SDF here. So you've got 2 outputs on this. The one that we're going to be using for now is just the first one, which is the kind of main color or value output. And we're going to hook that up to the side here. And we can set our resolution on this. You go to like 700. Okay. And we're now going to clear out the old 3D operators since we don't need those anymore. just cleaning up the network a little bit here. All right, so we've got a 2D render set up here, but it is not really showing us much useful output. And we can try kind of changing the scaling there of the rectangle, the width of it, and the height. You can kind of maybe make out a little bit of a shape there, but it's still kind of hard to see. And that's because this is using that sign distance function, and all it's doing is just producing the distance from each pixel. So if we if we look at the output here and then use this pixel values, you can see that it is producing values in there. They're kind of 0 in the middle here, and then a little bit larger as they go outside. And the further they go from the center, they get a little bit larger. So all this is doing is just showing that the actual distance that's coming out of this operator. So there are some times when that's useful, but most of the time, if you're just trying to like visualize a 2D SDF, it's useful to colorize it. So there's an operator for this. It's called Colorize SDF 2D, and it's in the material category. It's not the same kind of material that you use in ray marching, but it serves a similar function, which is why it's in that category. So if we insert this between the rectangle and the render 2D, you can see a shape. And what this is doing is it's taking this sign distance function, which is just producing a distance value, and it is converting that to colors. And it's got these inside settings, outside settings, and then an edge. And the inside settings are for parts of the output that are kind of inside, that are like inside the bounds of that shape. And it uses 2 colors and this period setting to kind of alternate, so it gives you a sense of what the distance looks like. If you don't want that kind of striped pattern, you can just set these to the same color, or but we're just gonna go back to showing it there. So it's got these settings for the inside, so the 2 colors, and then the period, which is like how tightly it spaces those stripes, and then another set of colors and another period setting for the outside area out there. And this view is primarily designed as kind of a window into seeing what a 2D SDF looks like. It's not primarily designed for kind of aesthetic output, but there are ways that you can use it for that. That's why the default settings are this kind of harsh color combination that makes it really obvious which part is where. But if you wanted to go with something a little bit more subtle, you could decrease this down to something close, or even just 2.5 or the same setting, or set this even to 0 to both of those. And you could do the same thing on the inside colors. So now all you have is the edge setting. So there's a toggle here that will enable or disable the edge, and a thickness setting that sets how thick the edge is. There's also this blending setting, which is responsible for smoothing out the transition from edge to not edge. So when it's at 0, you get a really hard edge. And so if you increase that to a larger value, then you can see it's kind of smoothing out that transition from the middle of the edge to the either side of it. So I'm going to decrease that blending, kind of bring the thickness back down. And for purposes of kind of understanding how these shapes work, I'm going to go back to kind of a default version of that Colorize. So I'm going to keep this other one here so that we can switch back to it later, but just for purposes of understanding it, I'm going to switch to kind of one with the default settings again. So right now we've got a rectangle SDF. So it has this scale setting which sets the size along the x-axis and the y-axis, and then also this translate setting that will move it around. And so this one's relatively straightforward. It's, it's a rectangle and has those two settings on it. There are a number of other ones for some kind of common shapes, like there's a circle one, there's a triangle one, so on, rectangle, rhombus, polygon. I'm going to create a polygon here, stick that in here. So this is got a couple of different kinds of shapes that it can render. Has this radius setting that picks the size, so you can go pentagon or hexagon or octagon. And similar to that one is the star SDF. So we connect that in here. So this produces kind of a star pattern where you can pick the number of points. So if you were to set this to 9 or something, you can pick any value there. You can also use fractional values. So in which case you'll kind of get a part of the star that's cut off or not fully symmetrical. And that part will be at the bottom. So if you want it to line up, evenly around the center, then just make sure to pick a whole number. So similar to polygon, it has this radius setting, which kind of picks the distance to that outer the outer tip of the points. It also has this tightness setting, which controls how much those inner points get pulled into the center. So if it's down to 0, then it's basically just a polygon. And this is a way that you can create some other types of polygons that aren't the ones that are supported by that polygon operator. But that operator is a bit more efficient. So if all you need is a pentagon or something, just use polygon instead. Star one is gives you more customization, but it's a little bit more complicated. So when you increase the tightness, you can see it's pulling in those inner points, and then if you go all the way up to 1, then you basically just have a set of lines. And these lines are infinitely thin, so they don't actually have a width. So the only reason that you're able to see them here is because the edge setting here has a thickness on it. So if you were to decrease that down, then it is just going to be showing the outside pattern. So if we set this to 0 and 0, decreases all the way down, then you get these thin lines. Just going to undo that, go back to those default settings there, and then bring the tightness down so we get an actual star shape. Some other SDFs that are available here. We already mentioned the kind of common shapes. There are some that are a little bit more unusual. So super quad is one example, and this uses a formula to produce a different range of shapes that kind of go from this very tight sort of cross shape all the way up to a rounded out square as you increase the exponent setting there, and then this radius picks the size of it. And so this one's useful if you want to get kind of a sharp curved point like that. There is also the pi SDF. That's pi is in the food, not the constant. And this gives you a slice of a circle, and you've got this angle setting that picks the number of degrees of width, and you can go all the way up to 360. It's important to note, though, that as you can see here, this is different than what just a regular circle would look like. So if we swap that in here, so regular circle is showing these distance lines are showing that there's kind of an even distance field around, like inside and outside it, that is kind of following the edge the whole way around. But the pi one, you can see it's still got this kind of inner edge, and all of the distances on the inside are based on that, so they get this kind of curved pattern. So if you decrease that down, similar to circle and other operators, it's a radius parameter, and then it also has a rotate, so you can swing it around. So another useful operator there is the corner SDF. So what this is a little bit different than the other ones that we've done so far, in that this is a kind of an infinitely sized shape. So it will produce kind of this corner, so basically a rectangle of infinite size that's got a center point wherever you set that translate. So if you move this all the way off, you can keep going forever, and you will never hit the other side of it. And so if we reset that, so it has this corner setting, so you can pick bottom left, top right, and so on, and it can be useful when combining with other shapes, which we will get to in a little bit. So I'm going to go back to the star here and then clear out some of these other ones. And for sake of organization, I'm going to add a null in here, and so that we can switch out our SDF a little bit more easily, without having to connect it to both of those every time, so that we can later on switch between them. You can use dat operators, and there are a couple of dat operators that are able to work with the things that get passed between the raw components. Most of them don't really make sense, but because this kind of the contents of that is sort of this internal data structure, but basic things like switch or select work like you would expect them to. So we can use a switch here, do that. And unlike the switch ROP component, so when this changes, it causes the shader to rebuild. And right now, because it's relatively simple, that doesn't make much of a difference, but if this were a much more complex scene, you would get a pretty noticeable pause every time that switched. So if you want to be able to switch that easily without having it freeze, you can use this switch operator here, which is pretty similar, but it lets you switch between them without that frame rate drop. But we're just going to go back to the other one since the scene is pretty simple and we don't need to be switching that around frequently. So now we're going to take a look at some filter operators. So many of the filter operators that we're used to from working in 3D also work in the two-dimensional space. So if we go down to some of the things like rotate, scale, translate, transform, those all also work in on 2D components. So if we swap in a rotate here and connect that up, you can see it will kind of switch to this single rotation value by default, because that's the only kind of rotation that makes sense in 2D. So if you use that here, you can see that it is spinning the shape around as one might expect. And other operators like that also work. You can use translate if you want to move the shape around. And with this, it uses the X and the Y, and then it just ignores the Z setting, since that doesn't apply here. So in addition to those kind of simpler operators, you can also use things like reflect. And this does is mirrors space around across an axis. So to make this a little bit easier to see, we're going to go back to using a rectangle for now. And we're going to use this rotate on it so that we can see that a little bit more easily. Okay, so you can see that it is kind of reflecting space across that middle axis, because it's currently using the X direction here. You can also use this custom setting and use like a vector, which will control how much of each axis it should reflect across, and with this and so it's important to note this is a vector, so it's kind of what matters is the relative value of these two, and not necessarily, so if you just have like one component, then it doesn't make a difference to change it, because it's just all x-axis, and that's all it needs to know. But if this one is, if the y-axis is something different, then it's a different ratio between the two. So you can use that if you want to use kind of a custom axis of reflection, but if you just want to go with, one of the axes, you can just go with, X. It also has options for the Z-axis, but as one might expect, that doesn't really make sense here. So if you try to use that, it will just kind of, it will skip that the whole operator and just not do anything. In some other cases, like it'll produce errors, or for other operators, that kind of thing would produce an error. But this one, it just kind of doesn't do anything if it doesn't understand what you're trying to do. So I'm going to go back to star here. And so if you can see, if you play with this rotate here, that you're getting that reflection pattern across that axis. And you can also use the operators that repeat space. So if you go to modulo 1D and move that, I'm just going to move this over a little bit and swap this in here, and then we're going to add a scale operator, just so we can see things a little bit more easily, and insert that between here. And when using the scale operator, it's generally best to use uniform mode unless you need to be doing the axes in different ways, or with different amounts of stretching. So you can kind of see here that when you start doing, just bypass that, when you start changing the axes separately, you can get these kind of distortions in the distance values. So unless you need to be doing separate settings, it's better to use uniform, so that will kind of produce consistent, it doesn't cause any distortion in the distance field. So if we connect that back to modulo 1D, so we're now zoomed out a bit so we can see more. This is, repeating space across the x-axis currently. You can also do y. You can use the mirroring setting, so if you rotate it, it will reflect like that. And so this could be kind of interesting for like a kind of gear pattern, but there would be a limitation. You wouldn't be able to have the two gears overlapping. So they'd get cut off at those border edges. So I'm gonna keep this for now and get rid of the reflect. So we've now covered some different 2D SDFs and some filters that you can use with 2D. And we mentioned earlier that you can combine 2D operators. So we're going to do that now. And most of the different types of combine operators will work with 2D. So if we create just a simple union, and we're gonna switch this off for now, and connect up these inputs. And you may notice that one of the differences in version 0.13 is that some of these operators will have even more inputs that you can connect. So this will do up to 8 different shapes. And so if we move this around there, you can see that it is just, combining those two shapes to make a single SDF that's incorporates both of them. You can also use the smooth union operator, which will blend between them. So, and you can control the amount of blending there. So you can see that it's smoothing out the transition between those two shapes, melting them into each other. And this is one of kind of useful things about the 2D view, is that it is a lot easier to see what the distance values are like when you have this kind of striped visualization. So you can see you can kind of get a sense of how those operators are working, and that it's kind of combining the distances between those two and blending between them. The combine operator, that's got kind of a bunch of different modes that you can use, also works. And we connect that up here, and we can move this back a little bit. So this has, simple union. It also has intersect, which will only do the overlap. Difference, which will subtract one from the other, and so on. It also has, stare operator, which is kind of a little bit hard to see in this case. But if we decrease we change this shape here, and we just go with like a circle instead of the star. And decrease the radius there. So this, stare operator does that kind of stepped transition between the two, and you can increase the number of steps or decrease it. And column is similar to that, just with kind of curved steps instead of squared ones, and so on. So we've covered this in earlier tutorials about the 3D operators, and they all, for a combine, they all work in basically the same way when you're dealing with 2D. It is worth noting, though, you can't combine 2D and 3D operators like this. So if you were to do a box here and try to hook that up, you will get an error, and it will, it's because it doesn't really know how to combine things from a 2D world with a 3D world just using those operators. There are ways that you can use 2D operators in 3D scenes, which is going to be covered in a future tutorial. But for now, we're just going to be working strictly in the 2D space. So I'm going to delete these other ones here and go back to star, and then move that out there and switch to, say, smooth union. we've got that shape there. So now that we've kind of explored some of the different operators, we're going to get to building the actual scene. So deleting that circle. So we're still going to be using this rectangle and this star, but we're going to center the rectangle like that. And just to make it easier to see, I'm going to switch off rotation for now. So make that kind of a thinner rectangle and then a longer shape like that. And so now, and switch back on the rotation. So now it's spinning that whole thing as one shape. But what we like to do instead is kind of spin them separately in different directions, different speeds. So instead of having one rotate after this combine, we're gonna have two different rotate operators on each one of these separately. That goes into that. So copy and pasting that, inserting it between both of them here. So now if you change one of them, it's only rotating one shape or the other shape. So now going to create another rectangle and another combine. I just copy and paste this one. And for now, just switches back to simple union. And we're going to connect that to, just disconnect this, connect that first output to the first combine, and the second one to this rectangle SDF. And insert that here. And we're not going to be using the modulo 1D, so I'm just going to get rid of that. So we've now got, another rectangle that's showing up there. But we're going to use a different filter on this that's going to flip it and flip it kind of inside out. So to do that, we're going to use the invert operator. And invert can be a little bit hard to tell. It can be hard to understand what it's doing, especially if you're in a 3D scene. But it's the 2D visualization makes it a little bit easier to see what's going on there. So just for the moment, we're gonna connect it this rectangle straight up to the scale there. And so now, right now, what we're seeing here is the shape where the red area is the inside of the shape, green area is the outside of the shape. So what invert does is it flips those two. So you can see there, it is this outer area is now now what it thinks of as being inside the shape, and the inside is what it thinks of as being outside. And so if you're using this in like a 3D context, you can use invert with a box SDF to make a hollow room, which can be a good element to kind of set scenes inside one of those. You just need to make sure that the camera is somewhere inside it, and so it isn't being blocked by the walls of the cube. So going to connect this back up here and go back to that. So we've now got this inner area that's kind of treated as the inside, and this or treated as the outside, and this other area is kind of treated as solid filled outside or inside. So if we gonna increase the size of this rectangle there, so basically what we're doing here is creating kind of a frame around the shape. And if we then change the setting on this combine back to smooth union and increase that radius a little bit, so now you can see that it will kind of, when the shape gets close to the edges, it will kind of blend into the walls around it. And as you spin it around, the middle one isn't close enough to actually connect, but this outer one, when it's facing certain directions, it will get close enough that it will blend into the wall. And so it'll kind of flip in and out like that. So now that we've got that, those scene elements set up, I'm going to add some animation to this. So just going to do a simple approach on this. Going to go with a constant, and we're going to have two different channels in here, one for rotate 1, another one for rotate 2. So these are going to be producing two different rotation values that we're going to use in each one of these. And we're going to connect that to a speed job. And we're going to add a math chop in here so that because we're going to be dealing with rotation, we're dealing with degrees, so we're going to need to have kind of larger values. So I'm going to use the multiply setting here, set it to something like 90, so that once we switch this on, we switch these on a little bit, you're going to get values that are, of a range that is appropriate for using as a rotation angle. And then we're going to add a null on the end here. And just to be nice and organized, I'm going to call this rotate vals. And we're now going to take these two channels and drag it onto the rotate here. You can use either chop reference or export. It's kind of up to your preference. I'm going to use chop reference, and now do the same thing with the other channel onto this other one here. So we've now got those two animating, but I'd like to flip that other one in the other direction. So I'm going to use a negative value here. So this is for the star, and the first one is for the rectangle. So you've now got those two spinning in opposite directions and then kind of blending with each other and blending with the shapes on the outside. And I'm going to go back to, so this view is useful for kind of understanding what's going on in the scene, but it's not, that pretty to look at. So we're going to go back to this other colorize mode and switch back to 0. So this is just using the edge only. So now we've got kind of a simple, cleaner pattern. It's kind of more aesthetically pleasing. If you want to add colors to the inside and outside, you can do that too. And if we were to go with, I don't know, some kind of a little bit lighter of a tone there, and then if you want to not have the striping, you could kind of copy those values there. And you could do something similar for what it's thinking of as the outside, which is now this region here, if you want to. But I'm going to go back to setting those to black and then just using the edge, and going to decrease the thickness a little bit there so we have a little bit sharper of an edge, or you decrease the blending rather, so we get a sharper edge, and then you can play around with the settings there to get something the way you like it. So this is kind of a basic version of the scene where you've got these two different 2D SDFs. They're each being rotated separately. Got those two rotation settings animated using these chops. We're combining those using smooth union. Then we've got this other rectangle that's kind of the outer frame, and we're flipping it on its inside out, and then combining that with that shape. I'm also using smooth union. And then at the end here, we're using a scale so we can kind of fit things more appropriately in the area that we're rendering. And then at the end here, we've got this Colorize SDF 2D, which is taking that distance field and turning it into this edge outline version. If you were to just bypass this here, So this is just going to be the raw distance values. And if you look really closely in here, or use this, display pixel values, you can kind of see the outline of the shape, but because it's just raw distance data, it's not in a range that's easily visible. So that's why this colorized SDF 2D is here to convert that into kind of a visible range. So we've now got that scene set up, and we're gonna start playing around with some more filters. So most of the filters that we've used so far have been things that are moving space in various ways, or reflecting, or kind of stretching things. The things that they're working with are about position and changing that in various ways. To visualize this again, we're going to go back to this mode here, set that switch to 1, so we can kind of see the distance lines there. So the operator that we're going to use now is called onion, and it's a little bit different from the other filters that we've worked with so far, in that it doesn't change anything about the position that it's of the things that are being fed into it. What it does is change the distance that comes out of those things. It will take a filled shape and turn it into kind of a hollow edge. And this ends up being pretty similar to what the Colorize mode does, and it's basically the same math under the hood that is the Colorize here is using to figure out what part is the edge and what part isn't. Onion does something similar, but it's operating on the distance field, so you can kind of work with that in different ways than if you're just dealing with color values. So it has this thickness setting, similar to the Colorize edge setting, but as you can see here, it is the thing that's coming out of this is another SDF distance field, which means that inside that edge, there's still this idea of distance from the surface on either side. And so that's what this thickness controls, is kind of how thick that shell is, and then when it's thick enough, you can see that there are it's kind of a filled area that has distances inside it, rather than just being like a solid color. So it also has this iterations setting, and what this does is repeat that process again a second time. So if you increase this thickness down there, so you can see now it's producing, a second shell. So what it's doing is converting it to that hollow shell, and then it's converting the edges of that hollow shell to hollow edges of hollow shells, and so on. So you can kind of bump that up and so on. You can bump that up to different values. If you get high enough, or if you get the edges are close enough together, then like they'll kind of merge together and be hard to see the difference between them, but you can play around with the thickness setting on that and the number of divisions that you're applying here. And if we go back to the edge visualization mode, so you've now got because we're doing this 2 times, you've got that 4-part edge, so it's dividing it once and then it's dividing each of those another time. So go back to one step, it's just doing a single split, and you can bump that up there. So we're just going to go with 1 for now, and we can play around with those settings however you want. Pick values that are in range, gives you the kind of image that you're looking for. So we now have this network that's producing this 2D SDF that is this, set this like hollow shell around that shape. And I'm going to use another filter, one of the common ones that we've used in a lot of the other tutorials, called mirror octant, because I don't know, it always produces interesting results, and It's usually worth trying to stick it into a scene and see what comes up. So similar to a lot of the other filters, this one can work in 2D just like the others. It's got this, size setting that is how far it's spreading apart. I'm just going to go to the visualization mode again here. So without it, it looks like that. With it, it is reflecting it across the x-axis, the y-axis, and then on those diagonals. And the size thing is spacing it away from those axes. So if you just do it on one axis, then it's just doing it there. If you do it in the other, it's along the other way. And if you do them the same, then you kind of retain that radial symmetry. You can also use this offset setting, which will, it's a little bit hard to see there, but it pushes, it pulls the shape away from or towards the axes. So you can use that in combination with the size setting to select different parts of the input shape that are being reflected. I'm going to go back to just 0, 0 there. I'm going to keep this at 0.2. And then we've got this rotate axis setting that will spin things, spin the shape before it does the reflection. So this gives you kind of that kaleidoscope effect. We've used this in previous tutorials in 3D space, but it works basically the same way in 2D. So playing around with that, you can get some interesting combinations. If you want to, you could also add another animation on that value, so it will change over time. See some neat spinning effects. Play around with that, see what you come up with, and so now that we've got things set up the way we like them, gonna go back to the first mode here, which gets you that the edge coloring that we had set up earlier. So to recap, we've got here is a 2D rectangle SDF and a 2D star SDF that are being rotated separately. They're being combined with smooth unions. They kind of blend into each other. There's this other rectangle that's kind of inverted to make that frame around the outside. Switch off mirror octant there. You've got the combine that's kind of blending between that and the outer edge. You've got onion that is splitting that filled shape into a hollow shell, and then mirror octant at the end that is reflecting it across the X and Y axes and spinning it. And then this scale at the end is just shrinking everything down. And the Colorize SDF 2D here is taking that distance field, which without it just looks like that, and it's using that to create this colorized image. And then that's going into a render 2D, which is taking this whole network and producing a 2D output.